Welcome back. Today, what we're going to be doing is looking at area of a trapezoid. Now, there's not any actual stuff in your textbooks about area of a trapezoid, but it is part of the grade 7 curriculum, and I love trapezoids. So I thought that we would talk about them today and that you would look through how to solve the area of a trapezoid. So you can see the goal for today is to develop and then apply the formula for the area of a trapezoid. And the way that we're going to do this is we're going to look at this problem. So Mr. Stevens told me that he wants Redeemer to install a trapezoid-shaped pool. The parallel sides would be 60 meters apart, and then in the winter, the pool would need to be covered with a solar cover. So Mr. Stevens, because he loves this stuff, wants to develop a formula to solve the area, or to solve how much canvas is going to be needed. So the question that we're thinking about is, what is the area of the solar cover? Now, what I've done is I've made up a nice little diagram. Movable, cutoutable diagram. This is a trapezoid. Trapezoids, they're quadrilaterals because they have four sides. The technical definition of a trapezoid is it's got two sets of parallel lines, one set of parallel lines and then one set of lines that are not parallel. So that is the basic definition of a trapezoid. What we want to do is calculate the area of this trapezoid. And so what I decided to do, we'll show you a couple of different ways about how we could do that. And the first way that we're going to do that is I've actually drawn out two trapezoids. There are two here. And what I'm going to do is I'm going to flip this one, and I'm going to put it right next to my original trapezoid. Now, hopefully, what you notice is that once you put those two trapezoids right next to each other like that, is that you end up with a parallelogram, which we know how to solve the area of a parallelogram. So here is how that works. Again, formula, area equals base times height. To get my base, what I need to do is look and say, hey, here's one part of the line and that I know is 40 meters, and here's the second part of the line that I'm told is 100 meters. So I have to add 40 meters plus 100 meters, which gives me 140 meters. So that's the length of my base. So I say it's 140 meters. I'm going to multiply it by the height. I know that the height is 60 meters because I'm told here that it's 60 meters. So do that multiplication. 140 meters times 60 meters is actually 8,400 meters squared. Now that number is the area of these two trapezoids together, which I don't necessarily want. In fact, I only want half of that. So I'm going to take my area number here of 8,400 meters, and I'm going to divide it by 2, which is going to get rid of this part. And when I've divided it by 2, I get a total area of 4,200 meters squared. So 4,200 meters squared is the area of one of these two trapezoids, which is the area of the solar cover. So to solve for the area of a trapezoid, you can use two trapezoids, one of them flipped around, to make a parallelogram, do a bit of adding, do a bit of multiplying, do a bit of dividing, and that will give you the area of one of these trapezoids. There happens to be a second way that we can solve for the area of a trapezoid. And what it is we can, this is going to be what's called example 1. And what we're going to do is we're going to calculate the area of a trapezoid using two triangles. And I'm going to draw this out freehand. Let's imagine for a second that we have this trapezoid. And I apologize for the freehand drawing. Okay, so, and let's say we're working with these numbers. 3 meters, 5 meters, and then the distance between the parallel lines of 3 meters. Okay, now what I'm going to do is I'm going to draw out a second one that's slightly different. No, sorry, a slightly different. Same measurements, however. So we have 3 meters, we have 5 meters, and then the height I'll put out here, which is still going to be the same, 3 meters. Now what I'm going to do is I'm actually going to divide this second trapezoid into two triangles. And the reason that I'm going to do that, secondly, I'm also going to label this stuff A, B, C, D. So what I'm going to be able to do now with this formula, or with this drawing the way it is, this one right here, is I can look at this and say I now have two triangles that I'm going to be able to combine afterward to find the area of this trapezoid. So what I'm going to do is I'm first going to use triangle ABC. And I know from yesterday that my formula is base times height divided by 2. So ABC is this one. So I know that the base is 5 meters. And I know that the height is 3 meters. And I'm going to divide that by 2. 5 times 3 is 15, and it's meters squared divided by 2, which equals 7.5 meters squared. So that's the area of triangle ABC. Now I can do the triangle of the area of triangle ADC, and again it's base. Move it over a little bit. Area equals base times height divided by 2. The base here is 3 meters because it's ADC. Height is still 3 meters divided by 2. 3 times 3 is 9 meters squared divided by 2, which gives me an overall area of 4.5 meters squared. Now, I found out the area of ABC and of ADC. It's this number and this number. So what I can do is I can add those two together, 7.5 meters squared plus 4.5 meters squared, which is going to give me an overall area of 12 meters squared. So that is the area of this trapezoid. It's 12 meters squared by dividing the shape into two triangles. Okay. Now, what I need to do is flip the page over, because I need to show you guys sort of a standard diagram for a trapezoid. I'll show you one more problem using my original solar cover. If we imagine for a second that in general a trapezoid looks like this, that's in general what a trapezoid looks like. I'm going to call this side A, I'm going to call this side B, and I'm going to call this H for the height. Okay. Now the reason that I'm doing that is back in our first example, we took a trapezoid, we doubled it up and we made it into a parallelogram. And what we had to do to find the base is we had to add the 40 and the 100. Now what that means is we added side A plus side B. So if we're trying to figure out a formula, the first thing that I have to do is I have to add A plus B. That's the first thing I have to do. In our original example, what I was able to do once I had added those two numbers, I was able to multiply that sum by the height. That's why A plus B is in brackets. So then what I have to do is I have to multiply it by the height, which in this case here was 60 centimeters, or 60 meters rather. And then once I've done that, I have found the area of this trapezoid, or this parallelogram, but I don't want the whole area of the parallelogram. I only want the trapezoid. I only want this one thing. So at the very end, I had to divide it by 2. This, grade 7, is the formula for the area of a trapezoid. It's A plus B, so the top side plus the bottom side, times the height divided by 2. Okay? So, if I'm working with this as my example, if I'm working with this original trapezoid, what I can do is I can say, okay, so I'm going to do 40 meters plus 100 meters, right? A and B, doesn't matter what number comes first, you add them together, make sure it's in brackets because you have to do that first, multiply it by the height, which is 60 meters, and then divide it by 2. So this brings us to 140 meters times 60 meters, divided by 2, order of operations, bring stuff down. Okay, this gives me 8,400 meters squared divided by 2, which gives me 4,200 meters squared. That is the formula. That is how you use it. Do your substitutions. Okay, this is the general side A plus side B times the height divided all by 2. Okay, and that's going to enable you to figure out the area of trapezoids.